Here we have a geometry problem on interior angles of a triangle. Okay, in the given figure, first let me mark the points A over here, B, C, D, E, and we have the markings over here and here. That is the length of this for BC and the length of this for DE are equal. Let me say the lowercase a represents the length of this BC and also this DE because both of them are equal in length. Now let's consider the triangle ACD over here. In this triangle, we know the measures of two interior angles are 30 degrees and 50 degrees. Then the measure of this interior angle has to be 100 degrees because we know that in any triangle, three interior angles will add up to 180 degrees. So when I take 100 degrees as a measure of this interior angle, so the three interior angles of this triangle will add up to 180 degrees. And here we have a straight angle. In this straight angle, this part is 100 degrees. Now to get the measure of this part, we have to subtract this 100 degrees from the measure of straight angle 180. Then we get 80 degrees over here. Okay, now let's consider the triangle ADE over here. In this triangle ADE, the two interior angles are equal. In a triangle, if two interior angles are equal, then it is an isosceles triangle. That is, the two sides will be equal. So the two sides which are equal to the interior angles of equal measure must be equal in length. So the side AD of this triangle, the side AE of this triangle are opposite to the interior angles of equal measure, that is 80 degrees. So then the length of this AD and the length of this AE must be equal. Let's take lowercase b as the length of AD and also AE over here. And now let's consider this interior angle over here in this triangle ADE. Okay, here we have 80 degrees, here we have 80 degrees, then the measure of this interior angle has to be 20 degrees. So because 80 positive 80, 160, 160 positive 20, 180 degrees. Okay, now let's consider this angle over here. So that is 30 positive 20, that will be 50 degrees. Now let me consider the triangle ACE over here. In this triangle ACE, the two interior angles are equal. That is, each one is 50 degrees. And this triangle ACE is an isosceles triangle because the two interior angles are equal. Now let's consider the two sides which are opposite to the interior angles of equal measure, that is 50 degrees. Okay, let's consider the side CD, which is opposite to the interior angle of 50 degrees. And also let's consider the side AE over here, which is opposite to the interior angle of 50 degrees. So since the CE and AE, both of them are opposite to the interior angles of equal measure, they must be equal. Already we know that, we have assumed the lowercase b as the length of AE. So we can consider the same length for CE, that is lowercase b. Okay, then what is the length of this for CD? To get the length of this for CD, we have to subtract A, that is the length of DE from the length of C. So let's subtract this lowercase a from this lowercase b to get the length of CD. Then we get B negative A. Okay, what is the length of this BD? Okay, to get the length of this BD, we have to add the length of BC and the length of CD. That is, we have to add this A and B negative A. When I add them, I am getting a B as a length. So the length of BD is lowercase b. Now let's consider the triangle ABD over here. In this triangle ABD, the length of the side AD and the length of the side BD are equal, that is lowercase b. So it is an isosceles triangle. In an isosceles triangle, the two interior angles which are opposite to the sides of equal length must be equal in measure. Okay, here this is the interior angle, that is x degrees, is opposite to the side AD over here. And this is the interior angle which is opposite to the side BD over here. Since these two interior angles are opposite to the sides of equal length, then these two interior angles must be equal. Since the measure of this interior angle is x degrees, then the measure of this interior angle is also the same x degrees. And already we know that the measure of this angle is 30 degrees. Then what is the measure of this part? Okay, now to get the measure of this part, we have to subtract this 30 from this measure, that is x degrees. Then we get x negative 30 as the measure for this part. Okay, now let's consider this part over here. Now to get the measure of this angle, let's consider the straight angle over here. It's 180 degrees. This part is 50 degrees. Then what is the measure of this part? It has to be 130 degrees. Okay, now let's consider the triangle ABC over here. In this triangle ABC, the three interior angles are x degrees, x negative 30 degrees, and 130 degrees. So these three interior angles will add up to 180 degrees. Okay, now let me do it. That is x positive, x negative 30, positive 130 equals to 180. Okay, when I combine this x and x, I am getting 2x. When I combine this negative 30 and positive 130, I am getting positive 100 equals to 180. Let me subtract a 100 from both sides of this equation. Positive 100, negative 100 will cancel out. I am getting 2x on the left side. On the right side, when I simplify this one, I am getting 80. Let me divide both sides of this equation by 2. Then this 2 will cancel out. I am getting x on the left side. On the right side, when I divide 80 by 2, I am getting 40. Okay, here I got the value of x, that is 40.